Okay, so today we're going to learn about applications of prime factorization. So hopefully you guys know what prime factorization is. Actually, somebody told me what prime factorization is, just to make sure that you guys know.
It's for prime numbers. You can multiply if you like every prime number, you can multiply to make that number.
Yeah,
Yeah, splitting a number into prime numbers.
yeah, basically that's what it is. It's basically when you take a number and you find all of its prime factors that multiply together to make that number. And so that's pretty useful. And sometimes questions will ask you stuff like, hey, how many factors are there? Or like, what is the product of all the factors in a certain number? Or what is the sum of all the factors of a certain number? And so that all requires you to use the prime factorization. So that's what we're gonna learn today. Okay, so the first thing is that sometimes questions will ask you, hey, here's this number. I'm going to say X. And the question's asking you, hey, how many factors does X have? So when they ask you how many factors does X have, one way to do it would be obviously to list out all of the prime factors. So for example, if I tell you, hey, find all the factors of 16, put in the chat, list out all of its factors.
Please say it again.
List out all the factors of 16.
Isn't it 2 to the 4th power?
Yeah, 16 is 2 to the 4th power. But right now, if we just brute force it, like if we just like think about it in our heads, what's the smallest factor of 16? That would be 1. What's the second smallest factor of 16? That's 2. And then 4, and then 8, and then 16. So if you list out all the factors and count how many there are, you can find, there's 5 factors. So that's like one way to count the number of factors in a number. But let's say you have a really, 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 really big number. For example, I'm just trying to think of a random big number. Let's say 900. 900, if you tried to list out all the factors in 900, that would kind of take you a long time. And we don't want to waste time listing out all the factors of 900. So there's another way to do it. So basically, the way to find, like, for example, like the number of factors of 900, and actually I'll start with a smaller number first, just to show you guys how to do it first. So we're gonna actually start with 36 because that's a bit smaller. So first, type in the chat, what's the prime factorization of 36? And type it in the form like the exponent form. So like, I don't know, a raised to the x power times b raised to the y power equals like 36. Like type it in that form. Yeah, that's right. So 36 is equal to 2 raised to the second power times 3 to the second power. So that's like easy to find, right? So then to get the number of factors, basically what you do is that you take each of these exponents. So I'm going to circle the exponents. So this 2 and the other 2, you take those exponents and then you add 1 to each of them. So now that one becomes 3 and the other one becomes 3. And then what you do is you multiply them together. So it becomes 3 times 3, and that equals 9, which happens to be the number of factors that 36 has. So does that make sense to everyone? It kind of feels like a hack, but it kind of is a math hack. So, okay. So that's basically the hack for finding the number of factors. And why it works is because any factor of 36, so which would be like, 1, 2, 3, 4, 9, 12, 18, 36, all of those are combinations of 2s and 3s. And so any factor of 36 factor of 36 is equal to a certain number of 2's times a certain number of 3's. So how many possibilities for the number of 2's are there? There aren't 2 possibilities, there's 3, because you can have 0, 1, or 2 2's. And that's how the possibilities for 2's. And then you could also have 0, 1, 2, or 2 3's. So since there's 3, notice how there's like 3 possibilities for how many 2's, 3 possibilities for how many 3's. Therefore, the total number of possibilities is 9. So that's where we get this is why we add 1 here, and then we multiply them together. Okay, hopefully that makes sense. Oops. Okay. So next, let's do, I guess, a practice problem. So how many factors of 190 are there? And don't list them out. Actually use like the prime factorization method to find it.
Wait, how do you find how many factors it has with prime factorization?
Yeah, just to review, for 36, what we did was we found the prime factorization, which is 2 squared times 3 squared. Then we took all of the exponents, we added 1 to the exponents, so they became 3. And then we multiplied all the exponents together to get the number of factors.
So take the prime factorization, add 1 to the exponents, and then multiply them together.
Yes, multiply the exponents together. Okay, so for 190, obviously the first thing you would do with the prime factorization method would be to find the prime factorization of 190. So 190 is equal to 2 times, I think, 5 times 19, I think. So there. But of course, all this is raised to the first power. Okay, so now we take these exponents, 1, 1, and 1, 1, and 1, and then we add 1 to each of those exponents. So now we get 2, 2, and 2 for the exponents. And finally, we multiply all those together. So that gets 2 cubed, which is 8. Easy peasy. Any questions about this? Okay. Let's do this. I think this one's too easy. 28 is easy. Yeah, let's do 1,000. Okay. How many factors does 1,000 have? Okay, I see lots of people putting 16 in the chat. Let's see if that's correct. So the prime factorization of 1,000, remember 1,000 is 10 cubed, this 10 times 10 times 10. And since 10 is 2 times 5, then we can just figure out that 1,000 is 2 cubed times 5 cubed pretty quickly. And then we take the exponents, which are 3 and 3. We add 1 to them, which gives us 4 and 4. And then we multiply them together to get 16. So yay, all of you guys were correct. So good job. Okay, let's try 588. Okay, I see some answers in the chat, so I'll go over this one. So 588. Holy cow! Oh my God, there's a ladybug. Sorry, guys. Ladybug just landed in front of me. I thought it was something else. That was a wasp. Okay, never mind. So 588. So immediately you can tell that this is divisible by 4 because the last two, oh my gosh. Sorry, the ladybug fell. Okay, the last 2 digits are divisible by 4. So therefore, we immediately know 2 squared is a factor. So after dividing by 4, we find that it's like 2 squared times 147. So at first, you might think that 147 is prime, but it's actually not prime. Why? Because the digits 1 plus 4 plus 7, that adds up to 12, which is a multiple of 3. Therefore, 147 is divisible by 3. So if we divide 147 by 3, we get 47, or sorry, not 47, 49. So that means this is also equal to 7 squared. So there. So the prime factorization of 588 would be 2 squared times 3 to the first power times 7 squared. So now we again just do that thing with the exponents. So we take all the exponents, we add 1 to all of them. Oh no, it's turning yellow down there. Okay. And then we get 3 times 2 times 3, which equals 18. Therefore, 588 has 18 factors. Yay. Okay, so now you guys know the basics about how to find the prime factorization of a number and how to like find the number of factors in the number. But there are other, sometimes the question will basically like, instead of asking you like, how many factors does this number have? The question might ask you, how many perfect square factors does this number have? Or the question might ask you something like, how many factors of this number are multiples of 7 or something like that? And but luckily you can still use this method for like weird questions like that. It's just you need to make like a slight modification. So for example, let's say, oh shoot, I'm not going to go through that whole thing. So let's do 288. Okay, so you're given a number, 288, and the question's asking you how many factors of 288 are perfect squares. So who has some ideas on how you might go about doing this? Like
Just divide by 2.
That's a good idea. And yes, Levi, first you do have to get the prime factorization. So in fact, let's just do that first. And so 288 is 144 times 2. So 288 is equal to 2 to the 5th power times 3 squared. Now, like Colin said, one thing you can try doing is dividing by like these exponents by 2. And the reason why you want to do that is because remember that a perfect square is like something, it's like a different number squared. That's what a perfect square is. And so whenever you look at a perfect square, its prime factorization, like all the exponents in a prime, okay, all the exponents in the prime factorization of a perfect square have to be even. So for example, 144 is a perfect square because it's 12 squared. But its prime factorization is like 144, okay, 2 to the 4th times 3 squared. So notice that all of these exponents are even. Therefore, when you're trying to find the number of perfect square factors in like something like 288, what you can do is that you take these exponents, you like, if they're even, just leave them be because that doesn't matter. But if they're odd, to like just take one out. So from 2/5 is now going to become 2 to the 4th. And then we're going to divide those like exponents by 2. So 4 becomes 2 and 2 becomes 1. and then you multiply them together, and that gives you 2. Therefore, 288 has 2 perfect square factors, I believe. Unless if I'm mistaken. Oh wait, I forgot to add 1. Crap. Sorry. Yeah, I forgot to add 1. Dang it. Okay. Let's go back a little bit. So after we divided by 2, don't forget to add 1 because I just made that mistake. So now it becomes 3 times 2 equals 6. So that's the number of perfect square factors. There we go. And I'll do it one more time because that was a little bit confusing. So 288 equals 2 to the 5th times 3 squared. Let me just confirm that. Okay, good. So now, because we're gonna, since the 5 here is odd, we're gonna take that and just subtract 1 to turn it into 4. And then what you do is you divide both of these by 2, because remember, it's a perfect square. So therefore, like every factor like that you have has to have a match. So this becomes 2, this becomes 1. Then you add 1 to it because remember in our normal number of factors thing, you have to add 1. That becomes 3 times 2, which is 6. Why did I turn the 5 into 4? Okay, so you have to turn the 5 into 4 because remember in a perfect square, all of the the exponents in the prime factorization have to be even. So therefore, basically think about it this way. If you have like 5 2s, in order to make a perfect square, you pair them up, right? But since it's odd, there's 1 left over. So you can just ignore that leftover 1 because in a perfect square, you can't have an odd number of like prime factors. So the maximum number of prime factors that a perfect square made from 288 could have is 4 2s, not 5 2s. Therefore, you can just drop it. You can ignore it. Okay. Does that make sense to everyone? If it doesn't, that's okay, because we're going to do a few problems. Okay. Kind of. Okay. Okay, let's just do one thing, one more problem. So, okay. How many? Okay, well, let me think of a good number to use. Okay, how many perfect square factors does 144 have? How many perfect square factors does 144 have? Okay, I see lots of answers. I see some people saying 2, some people saying 5, some people saying 6. I know you could list them out, but the thing is that if you list them out, you might make a mistake. Like you might forget a number. I know it is kind of similar to the last one. Okay, so the correct answer in this case would be 6, which is almost exactly the same as the previous problem. So, and this is why. So 144 is 2 to the 4th times 3 squared. The previous problem was like 288, right? And that is equal to 2 to the 5th times 3 squared. So the only difference between them is that extra 2. But the thing is that in our previous problem, because this 5 was odd, we just basically turned it into a 4 because it has to be even in order to be a perfect square. Basically, after that point on, these two problems are basically identical. So 144 is 2 to the 4th times 3 squared. Divide the exponents by 2 to get 2 and 1. Add 1 to each one. to get 3 and 2, and then you multiply them together to get 6 again. And if you want to know which perfect squares these are, I think these are 1, 4, 9, and then what's after 9? 16, 8, shoot,
36.
36, and then 144. So 6 total, I believe. Yeah, not 25. Okay. All right. So another like thing they could ask you is like, let's say you're given a number 360. How many factors of 360 are multiples of 6? So yeah, how would you go about doing that?
Just divide 360 by 6.
Yes, that is a very good start. Yeah, again, let's start by finding the prime factorization. So 360 equals 2 to the third times 3 squared times 5, I think. Yeah, okay. So this is a prime factorization of 360. And what you can do though is that basically we're going to just remove 6 from this prime factorization. And so let's just divide this prime factorization by 6. So the new prime factorization would be 2 squared times 3 to the first power times 5 to the first power. The reason we're doing this is because if you want all the factors that are a multiple of 6, well, and this is basically a multiple of 6 is going to be in the form 6 times something. It doesn't matter what this something is, as long as it's like an integer. But basically, oops. Okay, basically, it's just 6 times something. So you can just basically ignore the 6, just find, so take out the 6 from the 360, and what you're left with is all the stuff that you can use to make that something. And now we just find how many factors are in this new number here. So again, we go through our little procedure. You add 1 to each of the exponents. And now we get the answer 12. Yeah, so basically it has to be divisible by 6. Okay, does that make sense to everyone? Okay. If it doesn't make, oh, yeah.
So, so for the 2 squared over 3 squared, is it 2 squared times 3 squared times 5 to the power of 1 over 6? So it goes to 2, 1, and 1. How does that work again?
It goes to 2 squared times 3 to the first power times 5 to the first power, because after you divide by 6, 6 is 2 times 3, so the 2 goes down by 1 and the 3 goes down by 1. So basically, since like the factor has to be divisible by 6, you're taking out that 6 and pretending like it's already part of your factor, and then you just find how many factors you can make out of this new thing over here. And then that would, and so then you just treat it like a normal problem.
No, but how does it like convert to 2 to the power of 2, 3 to the power of 1, and 5 to the power of 1?
Oh, okay. So here, let me erase this. Okay. So 360 equals this, but then we're just going to take the 6 out. So that's why we're dividing by 6. And after we divide by 6, this ends up becoming the prime factorization of 60, because 360 divided by 6 is 60. So 2 squared.
Oh, I see. Oh, okay. Oh, all right. Yeah.
Yeah.
All right. I was making it complicated in my head.
That's okay. Okay. Yes. Okay. Let's do one more. Okay. How many, okay, factors of, let's do 120. Oh, that's a terrible color. Okay. How many factors of 120 are multiples of 5. Okay, I see a lot. Everybody has the same answer, I think. And you guys are correct. Okay. So, oh my gosh, the ladybug is back. What is it doing? Do you guys want to see it?
Yes, please.
Here's the ladybug.
Oh my god, it's so tiny.
Yeah, it's kind of small.
Revenge of the Ladybug.
Yeah. Whoa. Yep, that's the ladybug. Anyways, so first step, get the prime factorization of 120. So that's 2 cubed times 3 to the first power times 5 to the first power. And because we want to guarantee that the factors are divisible by 5, we're just going to divide this by 5. So this takes out the 5. So it ends up becoming 2 to the third times 3 to the first power. So then we just do our regular thing where we add 1 to the exponents. Oh no, the color is getting bad. We add 1 to the exponents to get 4, and then times 2. So that gets us 8 factors. And to Sanap's question, yes, this is basically the same question as if I just asked you, how many factors are there in 24? It's basically the same question. Okay, we're gonna, okay. Let's do, let's see how much time. Okay, let's do product of factors quickly. And then we can do, actually, we don't have a Kahoot today, guys. I'm really sorry about that. But we do have a booklet. You guys are like down here and then it's like up. Okay, anyway, let's get through product of factors and then we'll do a booklet. Okay, so product of factors. So basically, we just did the number of factors, but there's product. Sometimes the question will ask you what's the product of all the factors in a number and what's the sum of all the factors in a number. So for product of factors, basically the product of all the factors in a number x is x raised to the power of n over 2, where n is the number of factors of x. So basically, if you can just figure out how many factors there are in x, you can figure out the product of all the factors. So let's just do that. What's the product of the factors of 20? So first step would be how many factors are in 20? And then you would just plug that into n. 29. How'd you get 29? Okay, I see answers in the chat, so I will explain. So 20 prime factorization is 2 squared times 5 to the first power, which means it has 3 times 2 equals 6 factors. Therefore, prime factorization, or sorry, the product of all the factors will be 20 raised to the 6 divided by 2, or 20 cubed. Boom, done. Oops, okay, if anyone still needs that, it's, again, you get the number of factors, raise it to that power over 2, so 20 cubed. There,
Oh, I see.
okay. We're gonna skip these because I think you guys sort of get the point. But there is one sort of problem. Oh no, ladybug. Oh my god. Okay, sorry, it's fine. Okay, but there is one problem though. What about if I ask you what's the product of all the factors of 16? Now the thing with 16 is that it's a perfect square. So there is a problem. There's a very important problem. So how many factors of 16 are there? Well, there's 5 factors. Well, right, exactly. So if you raise 16 to the 5/2 power, well, what does that mean? Well, the thing is that is the thing. You can just do that. Like 1/2, basically what this means is that you raise, remember the exponent rules? This is basically 16 to the 4th power times 16 to the 1/2 power. In other words, this is 16 to the 4th power times the square root of 16, which is just 4. So that's 4 times 16 to the 4th power. So basically, don't let this fractional exponent like scare you. All it's saying is 16 to the 4th power times the square root of 16. So yeah. Okay. There's one more thing, one last thing, and then we'll get to the booklet. Sum of factors. This is a little bit tricky. Okay, so basically, okay, so sum of factors is something like this. So we're gonna find the sum of the factors of the number 20. So 20, okay, I'm gonna give you guys a formula, but it's a little bit of a weird formula. So 20 equals 2 squared times 5 to the first power, right? So we're gonna look at each of these individually. Oh my gosh, that ladybug. We're gonna look at 2 first. So we're gonna, basically what we're gonna do next is we're gonna find the sum of all like x. Here, I'll just show you guys. Okay, this is what 2 becomes. And then 5 becomes, oh no, that color. 5 becomes
5 to the power of 0 plus 5 to the power of 1.
yes. Okay, that's the formula. And that equals, okay, 2 to the, basically you find this
7 times
is
6, 42.
what? Basically you find this multiplied by the other one. 7 times 6 is 42. That's the formula. So now you guys have to do one problem to prove to me that you actually know it, and then we'll go to the booklet, okay? What is the sum of all the factors of 16? And do it like the way I just showed you guys, and don't like list out all the factors and add them up. Yay, okay, everybody got it. Okay, time to go to the booklet. Oops. I have no idea. Okay, disclaimer. I have no idea how booklet works. So
Press
yeah.
host and then you can
yeah, I
choose
mean,
mini game.
okay, I don't know what we're supposed to choose. So you guys are gonna, I guess, put which one you want to do one time into the chat.
Otherwise, it doesn't count.
Yeah.
Please don't ask.
Don't spam. I
Wait.
see you.
Not
If you do
crypto.
crypto-
Crypto's
I see
dog
one for
water.
tower.
If you do crypto, could you make it so that we're not allowed to share the passwords? Because that'd be unfair.
I see 3 for crypto.
Just do
Um,
Tower.
Monster
Just
Ball
do
would
Tower of
take
Doom,
18
or else
years.
crypto will win. People are changing their answers, and they're doing it twice. Schlock. Ari
Slow.
inputted 3
It's
different
slow, not
answers.
slack.
Okay. Is Tower of Doom and Tower Defense the same?
No,
I have no idea.
I don't think it exists. It probably
Okay.
doesn't exist.
Okay,
on
so vote
multiplayer.
between Tower and Crypto. Only type it in once.
Tower.
And Tower,
Crypto.
Crypto.
Yeah,
I see
Tower
a
does take a while.
lot for both.
Tower takes longer.
How long does it take on average?
I don't even know what your name is. 8, 1, 2, 4, 1, 2, 4.
Okay, should we just,
Yeah,
people are
around
saying
15.
Tower will take a long time, so we'll do Crypto.
Someone
Okay.
put
Is this
their
it?
name as Colin, but they're not me.
Is this one it?
Yeah, that's
Got
crypto.
One.
Okay. We've clicked this one.
Wait, is the
Okay.
code on the screen?
Okay. Some
I
product
could choose the time.
time. Okay. Boom.
No, you
Oh,
can change it
jeez,
at the
the
bottom.
music.
You can change the time at the bottom. Oh, I don't mind.
Where?
It's too late.
Oh, oops.
It's fine.
There's like 15 different Zoom icons on my screen, so like half of the stuff is covered up.
Chicken.
Look, it is very festive. Okay, we have 10 people in. We have 21 participants, so let's try to get a few more people. Okay. Let's see, which one is my favorite icon? This one is cute. This one also looks cool.
How did you get a background, Aryan? Do you just like grind this game?
He probably just got it. Like, I mean, honestly, I don't even grind the game. I could have gone it.
This one is also
I don't even know
cute.
how you
Yeah.
get a background.
Okay, you have to log in, like create account, log in.
Okay, we're gonna start
I mean,
now
you-
because
Good.
we're a little short on time. Okay, choose a password. Answer questions. Wow.
For me,
Find cryptocurrency.
you might not want to okay. No, stress.
Should I skip this?
Yeah, we all know how to do it.
Yeah.
Okay, so basically everybody except me knows how to do it. But I'm not playing, so.
Can you win this game just by guessing someone else's password?
Yeah, that's how you.
Oh, wow, I can scroll. Okay. Dang, maybe I should join. I want to see how this is like.
How did James get 65,000 crypto?
How did that happen?
Bro, why is everybody hacking me?
I'm hacking Amy.
Oh no.
I don't know who. I'm just guessing the
Me
password.
too. Tell me the choices.
Yes, I got the password right.
Bro,
What is
I
it? Tell
keep
me.
getting
I'm
this
hacking
one
her too. I'm
dude.
hacking her too. Tell me.
No.
What
I
is it?
keep getting one person who has
What is it?
20 crypto.
Amy's
and I
password
keep
is
having
like
to hack
pink
them.
cat. Amy's password is
Hey,
pink cat.
don't
No,
say
don't
How does
passwords.
James
Stop
have
that.
1.6 million? What the heck?
Stop saying passwords. Don't do that.
Bruh.
This
What's
is
James's
That's
password?
bad.
We need it.
3.2
Don't
million.
do. Come on, guys. Don't do that.
I'm hacking Aryan again for the second time.
Oh yeah, I hacked him like 3 times.
I just stole 11,000 crypto. Let's go.
This is just whoever is lucky enough to hack James.
Ah, take that, Amy.
Right.
Take that.
No.
I'm hacking someone
141.
else named Colin. What the
Are you
heck?
kidding me,
Oh,
bro?
hey, Sloko, yo.
Stupid.
I know your password.
Who's
is.
grass, bro?
No.
What is?
Who's grass?
Wow.
I'm hacking a different person.
Oh,
called Colin.
thanks,
Why is
Soap.
he trying to
go.
Thank
curse
you.
me or something?
Hey, I robbed James.
Oh my god. How do you get 3.2 million?
How did
Exactly.
that
That's
Okay,
stupid.
you rob somebody
Bruh.
and then you get lucky and get doubled once times. That's how it happens.
What?
If Amy
Doubles
ended up
and
1
triples.
second after, I would have gotten
Bruh.
like 20 million from James.
9 million.
No, I stole
This
from
is not
Sloko
even
last
funny
second.
anymore.
9
No, I
million,
was
bro.
hacking James. I got it correct, but then Amy ended it the second it was about to.
Bruh,
I didn't end it. The
9
game
million.
ended
She didn't end
itself.
it. She had a time limit.
James, how do you get 9 million?
He just got